slide up here. Thank you. I'm going to leave the slide up here for a couple minutes. So as we're kind of settling in here, if you could please use the chat function to introduce yourselves, tell us where you're calling or zooming in from, and let us know your answer to the question on the slide. How do you engage with shorelines in your region, and why is it important to you? And so we'll leave it up for a couple minutes. I'll give my answer just to get you started. So how I interact with my local shoreline, I do on a daily basis. I walk my dog along Dallas Road here in Victoria every morning and talk to other dog walkers and anyone who's about. And it's a way that I feel connected to my community.
Okay, Kyla, I'll just, now that we've got that started, I'll just introduce the three of you.
Okay.
So we have three speakers, a tag team tonight. And first of all, Kelly Loch, registered professional forester with a master's degree in forest science at University of Alberta. She's now the Salmon Projects Coordinator for Resilient Coasts for Salmon. And we also have Maria Catanzaro, a biologist for the Pacific Salmon Foundation in the Marine Science Program. She's the Salmon Projects Coordinator for Resilient Coasts for Salmon. And finally, Kyla Sheehan is also a biologist with Pacific Salmon Foundation. She has a BSc in Applied Biology from UBC and a Master's in Ecological Restoration at SFU and BCIT. So with that, as you can see, on probably the next slide, the Resilient Coasts for Salmon. That's what they're speaking about tonight. Nature-based solutions for climate change. So with that, I'll hand it over to our speakers.
Thank you. Okay, thanks everyone who participated in that little chat there. We'll definitely take note of what you said. It looks like there's lots of people who enjoy walking along the shoreline, like I said, exploring the intertidal and all kinds of things. Okay, so let's get started. Thank you so much for being here tonight, and thank you to the Natural History Society for having us. As Phil said, thank you for the kind introduction. My name is Kyla Sheehan. I'm the project manager of Resilient Coasts for Salmon. It's a partner program between the Pacific Salmon Foundation and the Stewardship Centre for BC. I'm calling in from Victoria on the traditional territories of the Lekwungen people where I live and work. And I'll let Kelly introduce herself if you wanted to say anything more, but that was some really great introductions from Phil. Thank you.
Thanks, Kyla, and thanks, Phil. Yeah, not much to add. I'm calling in from Cobble Hill, so I'm on the traditional territory of the Cowichan peoples. And in my role with the Stewardship Centre, I'm a Green Shores Projects Coordinator. I'm looking forward to tonight. And Maria.
Thanks, Kelly. I'm Maria Catanzaro. Philip covered it all. I'll just mention that I'm in the Lekwungen territory as well.
Great, thank you. Okay, so let's get started. I'm just going to turn off my video just because my internet's a little bit slow. So I'm here as long as you can still hear my voice. Thanks. Okay, so we're here to talk to you tonight about Resilient Coasts for Salmon. This is a new project focused on raising awareness on the interconnectedness of shorelines, people, and salmon. The Pacific Salmon Foundation, together with our partner, the Stewardship Centre for BC, has set out to educate BC communities about current and future climate impacts, including risks, vulnerability, and long-term adaptive benefits of nature-based solutions. So through this project, we aim to raise awareness, build professional capacity, and create visibility through shoreline restoration demonstration sites on Vancouver Island. And for our talk tonight, we're focusing on sea level rise and the importance of healthy, intact shorelines for resilience to climate change. And we'd really appreciate your feedback at the end. And I'll leave my email address as well if you'd like to leave any comments. So before we dive into the presentation, we wanted to take an inventory on the level of awareness for some specific terms that we'll be discussing today. So to answer this question, you can physically raise your hand if your camera is on, or use the raise hand function under reactions at the bottom of your screen. So for this question, how familiar are you with the terms overtopping, coastal squeeze, and hard armor. So first, if you could raise your hand for not familiar at all. Okay.
And I'll just take a moment to look here.
Thanks, Maria.
1, 2, 3, 4, 5, 6. Oh, it listed here, 6 participants raised their hand.
Oh, awesome.
Okay, oh, 7.
Yeah. Okay. And the second option, if your vote is for somewhat familiar.
And if you raised your hand, you can just, I think there's a button to be able to pull it back down just in case it's showing up again. Let's give it a moment. Okay, we're at 8 right now.
Okay.
Oh, okay.
And we'll go to the final option. Are you very familiar with these terms? Raise your hand if that's the case.
Okay, and we have 5. Thank you.
Thank you. One more question here, so you can lower your hand if you still have it up. So our next question is, are you familiar with the predicted sea level rise estimates for the south and east coast of Vancouver Island? So please raise your hand if yes, you are familiar.
Okay, we have 14.
Okay, great. And raise your hand if your choice is no, you are not familiar.
Okay, we have 11.
Okay, and raise your hand for the third option if you are sort of familiar.
Okay, it looks like it slowed down now. We have 13.
Perfect. Okay. Thank you for participating. So let's get into the presentation. I have an overview here of what we'll be talking about this evening. So to start off, we will situate ourselves within the Salish Sea and give an overview of why the ecosystems around where we live, work, and play are so valuable. And then we'll take a look at the coastal processes that shape and maintain our shorelines, as well as coastal modification and how it threatens those processes. Next, we'll provide an overview of the realities of climate change, namely sea level rise, on the southern and eastern coast of Vancouver Island. And finally, we'll discuss nature-based solutions and what we can do to be stewards of our shorelines. Then take a quick poll and then share opportunities for how all of you can get involved with Resilient Coast for Salmon. Now it's over to Kelly to start us off.
Thank you, Kyla. The Salish Sea is an amazing inland sea that includes the Strait of Georgia, Puget Sound, and the Strait of Juan de Fuca, and an intricate network of connecting channels, bays, and inlets. It spans the US-Canada border, stretching from north of Campbell River, British Columbia, down to Olympia, Washington in the south, and out to Nia Bay in the west. Next slide. The Salish Sea is home to approximately 8 million people. These coastlines are places where, as we all have been talking about, people love to live, work, and play. It's also home to many endangered species, such as the southern resident killer whale. Next slide. For all of us around the Salish Sea, it's important to remember that we share this ecosystem with the native wildlife and plants, and to respect that we are located on the unceded territories of many Indigenous peoples, including the Coast Salish. Next slide. And as British Columbians, many of us have grown up fishing and eating salmon, witnessing the annual migrations and spawning events as salmon return to local rivers. Salmon are woven into our cultures and our way of life on the coast. Salmon are particularly significant to coastal First Nations, whose activities throughout the year are centered around harvesting, preserving, eating, and celebrating this crucial food source. Through storytelling and ceremonies, Indigenous communities have passed down knowledge about the importance of salmon throughout the generations. In recent years, we have seen historically low salmon runs. In 2020, the catch of Pacific salmon was the lowest it has been since 1982. While not all species and populations of Pacific salmon are in decline, many populations of southern Chinook, coho, and Fraser River sockeye are in significant decline. And salmon are facing stressors from within the watershed and the marine environment, including forestry, agricultural runoff, and even a mix of chemicals that leaches from tire wear particles called 6-PPD. And now, in addition to all of these factors, salmon are facing additional stressors from climate change. Off to Maria.
Healthy shorelines nurture life on the coast in many ways. For instance, nearshore and estuarine habitats are critical to many species. You will find eelgrass meadows, kelp forests, and marshes that support a whole host of species, from birds to forage fish to salmon to orcas. These habitats support species with food, shelter, and refuge. For Pacific salmon, the nearshore environment is particularly important as they acclimatize to salt water after leaving freshwater habitats and search for food to grow strong enough for the open ocean journey. Healthy shorelines support forage fish as well, a critical food source for Pacific salmon, who lay their eggs in the beach sediment. Healthy shorelines provide access to food. When the tide is out, the table is set, is a common saying from Indigenous communities along the Salish Sea and beyond. Indigenous communities have sustainably harvested food from the sea since time immemorial. The cumulative anthropogenic pressures on shoreline and freshwater ecosystems impinges on their ability to harvest and secure culturally important food sources. These are also places that hold culturally and spiritually significant meaning. When shorelines are healthy, they can help build resilience to climate change for the natural world and coastal communities alike. These estuarine and nearshore habitats help buffer wave energy and impacts from the storms, and they can help reduce flooding and provide cleaner waters. For example, marshes help attenuate storm energy by buffering wave intensity. Next slide. However, healthy shorelines and the critical value they provide are threatened by coastal modification and climate change. We will discuss both of these threats and the impacts they cause. Next slide.
Let's start with natural coastal processes. So natural coastal processes both maintain and create our beaches, and they are needed to sustain our shorelines and their integrity into the future. Healthy beaches exist in a balance of erosion and deposition, where both processes occur simultaneously. The movement of sediment affects the shape and morphology of the beach and the suitability of the habitat for various species. For example, sediment is picked up and moved away by currents, waves, and wind. The waves scour and pick up sediment, moving it along the beach, and this is known as sediment transport. New sediment moves into these systems from eroding bluffs, rivers, and streams. When sediment is transported along the shoreline, it is deposited and accumulates in certain areas, and this is known as a sediment sink. Sediment sinks come in many shapes, including pocket beaches, sand spits, or areas on one side of a structure like a groin. However, through development, we have altered these coastlines and the way they function. One way we have modified coastlines is by hard armoring them. Hard armoring comes in all shapes and sizes, creating significant impacts to natural coastal processes. We add armoring to shorelines, thinking it's the best line of defense against rising waters. Seawalls and rock riprap, as seen here, and in the following photos, are all examples of hard armoring. Other forms of coastal modification include building piers and docks, and this shoreline modification impacts how beaches naturally function. So here we have some examples of hard armoring that has eroded. So on the far left, we see some rock boulders or riprap at the base of a coastal bluff. And these large boulders were probably placed here to protect the toe of the slope from erosion against rising sea levels. In the center, we see some steps down to the beach that have become eroded from the power of incoming waves, resulting in a not so usable pathway. On the far right, we see an armored pathway that is again showing erosion in the form of undercutting. In many urban locations around the world, more than 50% of the shoreline has been hardened by coastal armoring structures. Hard armoring can cause erosion, which can lead to shifts in critical substrate that forage fish species depend on for spawning. It can cause beach starvation, coastal squeeze, overtopping, or wave splash onto properties, reduction in shoreline vegetation, and degradation of neighboring shorelines. Not to mention that interruptions on one property create issues for adjacent properties. Erosion impacts human-made structures as well as natural features. Seen in the photo on the right of this slide is a portion of the Vancouver seawall after a storm surge earlier this year. The illustration on the left shows what happens when a seawall is put in. When shorelines are hard armored with seawalls and riprap, it prevents habitat from naturally migrating landward with sea level rise. As sea levels do rise, the high water line is restricted by those structures and coastal processes are impeded. This reduces intertidal habitat and eventually can cause a complete loss of intertidal areas and the species that use this space. This is known as coastal squeeze. Beach starvation occurs when beaches are cut off from their source of sediment. Deposition and erosion occur in harmony at the shoreline, but when structures like groins are installed, beaches are cut off from their supply of sediment, and the dominant process becomes erosion. As a result, areas with hard armor will often experience a shift in substrate type. If the area is sandy, it may become more gravel dominant, since sediment may no longer be nourishing the area. In developed areas, there is typically a net loss of tree canopy and other vegetation. Intact vegetation, rather than paving or pathways or armoring, keeps sediment in place and allows rain to soak into the ground. When vegetation is cleared for building, erosion can become a significant problem. Cutting down overhanging vegetation on the shoreline also reduces the amount of terrestrial insects that fall into the water, which eliminates a key connection to the marine food web. Overtopping occurs when hard armor is present. And as you can see in the illustration on the left, since the natural shoreline slope has been removed, waves cannot dissipate like they are meant to. Instead, they crash against seawalls, which worsens erosional force, but also produces wave overtopping and spray onto the other side of the wall. And here are some good examples on the left of an incoming wave overtopping a hard armoring structures, and coastal squeeze occurring in the center and right photos where local beaches have been cut off to the public and incoming debris batters the shoreline. So how does coastal modification impact salmon? Well, throughout British Columbia, residential clearing and shoreline armoring, coupled with the impacts of sea level rise, affect the sustainability of nearshore processes and threaten high-value habitat, including areas where forage fish like surf smelt and Pacific herring spawn. This has huge implications on the entire coastal food web, which includes Pacific salmon. Did you know that armored shorelines impact the diets of Pacific salmon? Studies have found that shoreline armoring reduced the number and diversity of epibenthic invertebrates. And these are the critters that reside on or above the rock, sand, and mud of the seafloor, compared to unarmored shorelines. So as a result, when young salmon are next to a seawall and other artificial structures, they end up feeding on alternative types of prey that might be harder to catch and are less nutritious. Research has shown that growth in early stages for juvenile salmon is critical and can predict overall health and survival for them as adults. Coastal modification also disrupts the overall land and sea connectivity, cutting off the shoreline from natural overhanging vegetation in the riparian zone. Surf smelt, a prized prey species for salmon as they grow in these coastal areas, also suffer without overhanging coastal vegetation. The shade of the vegetation regulates the temperature of the upper shoreline, and this is important for successful surf smelt beach spawning. Quality shallow habitat is also lost under traditional overwater structures like piers and docks. The areas beneath these structures are bleak. The structures cast too much shade, so seagrasses and algae cannot thrive below. Salmon also avoid these areas. It's too dark, and the lack of light seems to make salmon nervous. They also cannot see their predators, find ample prey, properly orient themselves, or school together. And they end up altering their natural behavior and avoid the shallow areas that should be their safe havens with plentiful food. So the bottom line is that reducing the amount of armored shoreline and preventing future armoring is critical to the ecological resilience of BC's coasts. However, the fact remains that sea levels are rising and protecting our communities is a priority. So we'll briefly cover climate change for eastern and southern Vancouver Island, followed by a more in-depth account on sea level rise and how it pertains to healthy functioning shorelines and coastal communities.
As a result of human-caused increases in atmospheric greenhouse gas concentrations, the world is facing unprecedented climatic changes, and British Columbia is no exception. In eastern and southern Vancouver Island specifically, we are already experiencing warmer air and sea surface temperatures and rising sea levels. Extreme events, such as the record-shattering heat dome of 2021, will also be more common. There will be changes in seasonal precipitation patterns, which can result in increases in periods of drought and more frequent and intense storms. During the winter months, the dominant precipitation type will be rain instead of snow. This can cause severe flooding like we've been experiencing here in BC. We observed all these consequences in November of 2021, when a series of intense atmospheric river storm events dumped record rainfall across southern British Columbia. This flooding is likely to be the most costly natural disaster in Canadian history due to all the infrastructure and property damage. It is expected that the event will severely affect several populations of salmon. Next slide. Projected global sea level rise will be between 30 centimeters and 2.5 meters by 2100. This wide range is mainly due to the uncertainty in the response of the massive Greenland and Antarctic ice sheet disintegration to regional warming across a variety of future emission scenarios. The impacts of rising sea levels are anticipated to vary markedly among the coast due to local topography, currents, geological processes such as tectonic activity and post-glacial adjustment. Modeling of the low to intermediate emission scenarios suggests that much of the Pacific Northwest will experience less sea level rise than the global average. Sea level rise is projected to be the greatest on the North Coast, the Fraser Lowland, and southern Vancouver Island. Projections by the year 2100 range from 50 to 70 centimeters, which doesn't account for the possibility of the Greenland and Antarctic ice sheet disintegration. While the rest of the Vancouver Island is projected to experience a much smaller relative rise in sea level. In Victoria, the sea level has risen at a rate of 6.6 centimeters per century, and this rate is accelerating. Even at the modest end of this range, our coastlines as we know them will be inevitably changed. Next slide. Together, the different impacts associated with climate change can work cumulatively to result in even greater consequences and challenges for the environment and coastal communities. In addition to increasing sea level, these regions will also experience increasing wind, wave height, and storm intensity. This increase in storm intensity is expected to create even greater storm surges, leading to a heightened potential for shoreline erosion and will cause low-lying regions to flood with regularity. Other challenges will include saltwater intrusion, which can greatly impact wells and drinking water and agriculture. The financial implications of sea level rise in combination with extreme weather events are huge and are already being felt by a growing number of homeowners and communities across British Columbia. Equally significant are the ecological and social implications. Next slide. What will become increasingly important in the future is the resilient and adaptive value of healthy, intact shoreline systems in the face of climate change. Natural shorelines are dynamic, and given the space to move, will adjust to rising sea levels and buffer storm energy. This capacity will help protect our coastal communities from storm surges and higher sea levels. Promoting healthy shorelines will also help ensure we do not lose habitats that support critical links in the food web, such as forage fish. Next slide. So change along our coast is inevitable because that's what coastal processes do. They make our coastlines dynamic. Any interventions we choose to do are temporary because natural processes will prevail. So it's in our best interest to work with nature and not against it. Now we will go on to discuss ways that we can make a difference.
There are lots of steps that we can take as homeowners to protect the natural world. And everything we do on the upland does indeed, in fact, they impact the shoreline and aquatic environment. And for example, we can reduce the amount of impervious surfaces such as paved driveways we have around our homes. These are areas that don't allow rainwater to soak into the land, so contaminants can flow directly overland into storm drains and ultimately into waterways. This diagram shows the many potential ways that contaminated runoff can enter the aquatic environment. So the roof, off of gutters, off the street, lawns, ending up where we don't want it to be. By replacing paved driveways with pervious pavers and planting more native vegetation in the upland, potentially harmful runoff can be reduced and filtered, and groundwater supplies can be recharged. Rain gardens are another great method to accomplish these objectives through designs that include a swale type structure and water loving plants to hold and collect runoff. Next slide. Specifically along shorelines, we can take steps like revegetating the riparian area with native plants well adapted to local conditions. Plants that grow in this area above the high water mark are important for stabilizing the shoreline and providing critical habitat. Insects and plant material that fall into the water feed the marine species like Pacific salmon, because terrestrial insects are an important part of their diet. And when this vegetation is abundant and overhangs the shoreline, it also provides shade and cooler areas where forage fish can spawn, because they ride the high tides to spawn sediment on the beach. Removal of invasive plants is also important to avoid competition with the more beneficial riparian plants. Next slide. When it comes to nature-based solutions along the shoreline, the best thing is to try to design shoreline restoration in a way that avoids building along the shoreline. In locations with existing infrastructure, using accommodation, for example, elevating the infrastructure, or retreat by moving a structure back from the shoreline, are also strategies to adapt to sea level rise. And we can move away from hard armoring shorelines, and instead of seawalls, we can hire professionals to restore shorelines with nature in mind. This involves coastal geomorphologists, coastal engineers, landscape architects, and biologists. And some of the restorative actions that can be considered are, firstly, to regrade the beach to mimic a more natural angle which absorbs and slows down wave energy. This can also help to retain natural woody materials such as drift logs that collect up at the high water mark after a high tide event, which provide further stabilization and habitat for the beach. Beach nourishment is another alternative in places where shorelines have experienced a loss of sediment due to erosional forces that are worsened by hard armoring. Beach nourishment is a process of replenishing the sediment. By working with someone with fisheries expertise, sediment mixes can be designed for a particular site. There are even some specific mixes called forage fish mixes. And when these were used at a site in Samish Nation territory, they saw surf smelt spawning the very next day, apparently. Professionals can also place logs at sills to be sills at some sites to help hold back the new sediment for a longer duration. And all these techniques can incorporate sea level rise estimates. There are also restoration professionals who restore marsh and estuary habitat, and these ecosystems naturally attenuate wave action and provide vital habitat. Overall, by working with nature for a shoreline restoration design, we can adapt to our changing climate and support both humans and the environment because they are connected. Next slide. This is a cross-section of what a natural versus a modified shoreline looks like. Nature-based solutions for the shoreline hope to achieve the attributes shown on the right of this diagram. Wave energy can be dissipated as it runs up the shoreline over natural materials. The native vegetation provides habitat for organisms that are crucial food sources for the marine species like Pacific salmon and provide shade to forage fish who spawn below. And humans can access and enjoy the shoreline more readily. Next slide. And some people have gone on one step further to receive certification from Green Shores. Green Shores is a voluntary incentive-based rating program focused on positive steps to reduce the impact of development on shoreline ecosystems. Green Shores is a Made in Canada initiative of the Stewardship Centre for British Columbia, which uses a multidisciplinary integrated framework for shoreline management by encouraging adoption of nature-based solutions for the design and construction of projects on both marine and lake settings. Those trained in Green Shores can assist homeowners with bringing the right professionals together to create a restoration plan and process. Green Shores is built on 4 key principles. Firstly, to preserve the integrity or connectivity of shoreline processes. Secondly, to maintain or enhance habitat diversity or function. To minimize and reduce pollutants to the shoreline environment, and reduce and hopefully even reverse cumulative impacts to the shoreline system. Those that seek Green Shores certification are often early adopters and are keen to maximize environmental benefits. This slide shows a family with their Green Shores home project in Cowichan Bay. The family with the Kenneth, the homeowner, is an architect that teaches at Vancouver Island University, and they achieved Green Shores for Homes gold certification level, the highest level. And they were actually seeking out a number of certification levels for their project with their home building and everything. And we find that these people are ambassadors for environmental projects in general and for Green Shores to help understand the benefits of them. Next slide. Every bit of effort does matter to reduce the cumulative impact of development on shorelines. Opportunities like reducing the number of docks that are built along a shoreline, or even sharing a dock if one is necessary, while utilizing best management practices for the construction and maintenance of these structures are great examples. We can utilize salmon-friendly designs for overwater structures. If you're building a dock, you can use fewer pilings and have your structure sit above the water like a bridge to allow more light to shine through. It's also important to use grading that allows light to penetrate through to the water below, so that eelgrass and other aquatic plants can grow to provide valuable nearshore habitat for salmon. The wall on the right here, shown in this photo, is a great example from the city of Seattle. They set out to increase biodiversity, habitat value, and even habitat connectivity along their waterfront by installing glass blocks and grading that allows light to penetrate the pier. Surface complexity was added to seawalls to mimic a natural shallow habitat and provide critical food sources. Waterfront parks in the area were also converted into beaches with backshore habitat value, and together these efforts have turned areas of habitat that was actually lost long ago into areas that are usable again for salmon. Slide. So you can look into joining local stewardship groups to help with riparian plantings, eelgrass restoration, and even forage fish monitoring. We have a map of all the stewardship groups on Vancouver Island at our resilientcoast.ca website. Next slide. And we would love it if you could check out our website, for example, the toolkit section, for more information on how we can all make a difference. I'll pass it back to Kyla.
Great, thanks everyone. So we're just going to wrap up by coming back to our poll. So we're going to revisit one of the questions that we asked here. And again, you can use the reactions function to raise your hand to answer this question. So the question is, how familiar are you with the terms overtopping, coastal squeeze, and hard armor? So if you could please raise your hand if you choose not familiar at all. Okay, and raise your hand if you are somewhat familiar. And finally, raise your hand if you feel you are very familiar with these terms. Excellent, thank you. Okay, one more question for you. What are the predicted sea level rise estimates for southern and eastern Vancouver Island? So if you can raise your hand if you feel unsure about the answer of this one. Okay, and raise your hand if your answer is it depends on which part of the south and east coastline of Vancouver Island you are referring to. So maybe it ranges geographically. Great. And raise your hand finally if your answer is the results are the same across all the south and east coastlines of Vancouver Island. Great, thank you so much. And our last question, just an open question here, but did anything in our presentation specifically stick out for you? What is the most important takeaway that you want to bring with you? So feel free to raise your hand if you would like to comment and turn your camera on and speak, or you can leave us a note in the chat box. Otherwise, we'll open the floor up for some questions.
Okay, thank you,
Thank you.
all the speakers, Kelly, Kyla, and Maria. Are there
Thank
any
you.
questions? So if you do have a question, you can put it in the chat and I can ask the question, or you can do it live if you want to.
I
turn
see a
on your
couple
screen.
hands up here.
Can I do it live? Oh,
Sure.
hi, this is Melissa Anderson. I remember reading way back in, I think it was 1998, Silver Donald Cameron's book, The Living Beach. And he talked a lot about sort of seawalls and things. But the problem being that if you were trying to do the right thing, say, and got rid of yours, and the person next to you had one, their seawall would create the erosion scooping out on either side. So I don't know what mechanisms there are with private property owners to kind of get a coordinated approach to either removing or reducing the hard armor of seawalls.
Yeah, that's a really good point. It definitely takes a community to make a big difference, but we definitely believe that one coastal property owner can also be kind of the flag holder and get things started in their community. Kelly, I don't know if you wanted to add anything from a Green Shores perspective about that.
Just that it's almost like a culture shift away from shoreline protection, because when they fail, it's a catastrophic failure. So we're really trying to, where it's applicable and coastal processes are amenable to it, trying to use a nature-based approach. The softened shoreline use of hybrid design has a buried revettement. So there's actually a reprofiling to the beach to provide a little bit of that same protection that a seawall would do, but in a more natural way. So I don't know if that answers your question, Melissa, or.
Yes, thank you.
So there are a few questions in the chat. I'll read them out. One asks, David Fraser says, have any BC locations used the same technology that you showed from Seattle?
Not to
Maria?
my knowledge.
Okay, Maria, thanks.
But we're hoping that by doing these types of presentations and reaching out to different groups that we can encourage this so that they can enhance these areas, so they can support species like salmon and forage fish, instead of just being, you know, a bare seawall.
There's another question here. Given the extirpation of sea otters in the Sailor Sea, we must have lost kelp forest due to sea urchins, which are excellent at slowing waves. Can kelp forests be encouraged in the absence of sea otters?
What was the last part of that?
Can kelp forests be encouraged in the absence of sea otters to help?
Well, that one's kind of a complicated one because there's a lot of factors that are affecting the health of kelp and their persistence. And so a lot of researchers are studying this right now, and they're looking at warmer temperatures and how that might affect kelp and where they're situated. So if they're at the end of an inlet, they seem to be more susceptible as well. So it's a little bit more complicated than that, but yes, some studies are looking at the wave attenuation by kelp forests, but there's a lot more to kind of figure out.
Yeah, there's a lot of research going on, as Maria said, especially at PSF or in partnership with PSF, about identifying resilient areas of kelp, so resilient communities, and that's resilience to different temperatures. So what are the strongest ones?
I'll just add that Green Shores does give credit if a restoration project is able to establish kelp in the aquatic environment. So it's very much recognized as being important. So, and hopefully all the study will help us to be able to do that more effectively.
Mhm. Any other questions? I was just wondering if what's the proportional effect of damage to spawning beds, like in the creeks and rivers, versus the near shore problem? Is it proportional, or is the spawning the more important in terms of salmon populations?
That's a very interesting, very big question. Yeah, with our focus, it's mostly on the near shore, and so we're looking at the entire coastal food web, and a big part of that is forage fish spawning, and so those beaches are very critical in the life cycle of Pacific salmon, especially. So I'm not sure I can give a definite answer of which is more important, the spawning habitat for salmon or the nearshore environment, but both critical.
Mhm. Yeah, and the spawning substrate is obviously threatened by a lot of the flooding and large storm events that we have.
Yeah.
Sometimes the spawning gravel changes in size or gets, kind of buried with a lot of sedimentation. And so, yeah, they're facing threats in all phases of their life cycle.
Mhm.
Maria, Kyla, can I contribute to that?
Please,
Yes,
join in,
please. Hi,
Jacqueline.
Jacqueline.
Hello. So one thing around the big thing is, of course, you're talking about, you're gonna have the spawning, you need to have like those that's a critical life stage. But then another critical life stage for salmon to be able to even return is what's going on in the ocean, whether they're actually able to feed, strengthen themselves up, and return back. And so basically you're looking at two critical life stages that exist for salmon. So having threats to coastal habitat that is very important to their food source, you're causing a significant disruption and stuff like that. And with some of the work that's being done out of the Juanez lab, they've really identified how critical Pacific sandlands are to the foraging of for Chinook salmon down and around the Harrow Strait and in these distinct regions, areas of the whole Salish Sea. And in that area is also that critical overlap for the southern resident killer whales. And so if you're beginning to notice that, of course, Chinook salmon there are suffering because, of course, there is these impacts and threats to these key food sources in the areas where these larger predators are even feeding. So we're looking at two critical life stages for these fish. And so I would say both are probably a good contribution to that.
Okay.
Thanks, Jacqueline.
I got a quick question here from Mick Collins. There's through the Islands Trust and around the Gulf Islands, there's a tendency to want to make it more and more difficult to for people to put a dock in, a private dock. Do you have any observations about docks and best case practices? It's currently a provincial responsibility, and there's a pretty strong movement on some of the Gulf Islands to actually require homeowners to go through rezoning as well as provincial authorization. So I think the whole business of business docks and using the best technology is pertinent in all of this discussion as well.
Absolutely, Mick. Yeah, it's a big problem, docks. I mean, if people can share with others, if they do need to have one, then that's the best route to take. And as Kelly mentioned, they can use like fewer pilings, so it's higher up. So there's more light that can penetrate through, and use more grading as well for that light as well, because there's a lot of species that would be naturally living in that area, like eelgrass, and they need light to survive and to thrive and grow. So And that's a critical habitat for species like Pacific salmon who go in there to find shelter and food and refuge. So yeah, all the docks that are being put in, that will just eliminate eelgrass and many other negative impacts. So I'm not sure if I answered your question properly, but.
Yeah, I think in terms of, you know, transparent docks, and, you know, some people would argue that docks actually, when stuff grows on them, provide habitat, and depends on the materials you use. So I'm just suggesting it as an area of research before people say all docks are evil, that if there's any light that you can shed for people who are going to want to do that, that they're using the very, very best technology and science. And I think a lot of it is very site specific. And that's why when people apply for docks permission, they presumably have to look closely at the site and what's going on at the site. So I'm just suggesting that there's a tendency to want to focus on green shores and armoring, but this whole dock issue is a really growing one, and I'm not sure that people have all the answers on it yet. So I'm just suggesting that's an area of further research and best case practices for your group.
Yeah, thank you for that suggestion. And you make a really good point about there being excellent technologies out there already, alternatives for materials and things like that. I'm not too familiar with the research that's been done. We did have a look at that seawall down in Seattle, and that's very interesting what they're showing with the textured seawall and that creating habitat. But for coastal homeowners, I think a big piece towards making any positive change is education. So once we know what the real technologies are and the positive shifts that we can make, is getting the word out to those homeowners, not only about the best practices, but why they're important. So giving talks like we did today about what are the habitats in those coastal communities, what are you protecting, or what are you potentially impacting? Thank you for that.
Great, thank you very much.
Okay, thanks for that question. Are there any other questions for our panel? Doesn't seem like it. So there on the screen now is a website for Resilient Coasts. So if you'd like to look up more about that, if you write that down. And in the meantime, I'd like to thank our speakers for lots of food for thought and things we can do as homeowners. Those of us lucky enough to live on the seashore, especially, but even when you're not near the seashore, you can try and increase the type of land that will absorb water instead of repelling it. So thank you all for your presentations.
Thanks so much for having us.
Thank you, Philip.
Thank you, everyone.